Hi all! Today Anthony and I will be going over some fun stuff.
Yeah, we'll be going over some exciting parts of physics.
Today's topic is how position, distance, and displacement are all different.
Say what? Those are my favorite.
They're mine too.
Well, Anthony, glad you're excited. Let's dive in. To start off, the definition of position is exactly where an object is located at a moment in time.
Wait, so would a ball on a rooftop be a good example?
Yes, the ball is the object, and the rooftop is the precise location. In order to graph a position versus time graph, we need to know where the object is at that moment, and where it is going to end up at a given amount of time.
Great! Could you show me?
Yeah, so it starts with drawing the x and y axis. Labeling to make sure you know what is what. For this situation, the x-axis is labeled in seconds, and the y-axis is labeled in meters. Then drawing where the ball will be within this given time. For position versus time graph, all you need to know is how long it will take for the ball to get from the start to the finish. Let's say that the ball takes 3 seconds to hit the ground from 10 meters in the air. We can then mark that on the graph. Now that we have the start position and how long it hit the floor, the next thing we need is a line to give us a picture on the motion of the ball. So let's say you need to get to school. If you were to draw a straight line from your house to your school, that would measure the displacement. How far away you ended from your starting point you've traveled, even if you've gone through streets. But the path including all the streets and turns you took would be the distance. The car went north for 3 seconds at 5 meters per second. Then it turned around and went south for 3 seconds at 5 meters per second. What is this distance and displacement?
So here, you can pretend that this way is north. So you would look at it and you would see that the car went north for 3 seconds at 5 meters per second. So every second, it went 5 meters. So you just do a simple math equation, 5 times 3, and you find that the car went 15 meters north. And then the same thing could be done going south, and you would end up getting the same number, 15 meters south. You could see that these numbers cancel each other out, so the displacement would equal 0. But it traveled 30 meters. Boom. So if you look at the problem, you can see that the car was going 5 meters per second for 3 seconds, which means that after every second, the car went 5 meters in the northern direction. So then you can just draw that straight line, and that'll show you the movement of the car for that period of time. And then when you look at the second part of the equation, you see that the car went back south for this amount of time, which would generally, for this situation, just be the exact same line opposite in the other direction. What this graph would show you is that you can see that on the x-axis, the car is ending on the same place that it started, which would make the displacement equal to 0. But if you look, it travels a distance of 15 meters going up here, and then another 15 meters going back here. And if you added those up, that's when you would get your 30 meters of your distance traveled. Boop! So let's take a quick recap. Position. That is where an object is located at an instant in time. So right now, this ball is on the rooftop, and that is its position. Now for distance, that is the total distance that you've traveled in general. Let's say this is 15, like it is how far you traveled. But displacement is how far from your starting point you ended up, which would be this line right here.